This is day 4 of graphing rational functions. The primary topic of today's video is end behavior. The end behavior of a graph is the behavior of the graph as it approaches positive or negative infinity, and this can happen in either the x or the y direction. So let's take a look at the first problem here. There is some new notation, so I'm going to read this statement, and I want you to pay attention to the words I choose as I read each symbol. So this says, as x approaches 3 from the positive direction, the value of the function approaches what? So first is the arrow. The arrow means approaches. And next is the symbol, the small plus or minus following the number. The plus means from the positive direction. And the minus means from the negative direction. So the first one, as x approaches 3 from the right. So let's look at our graph. At x equals 3, there is a vertical asymptote. So what we were trying to find out is the value of this function as it approaches that vertical asymptote. First, we're going to look at the value of the function as it approaches from the positive side. So this is going to be from the right. As this function approaches the asymptote, you can see that the function value increases. And this is going to continue to increase infinitely. So f of x approaches infinity. Next, looking at it from the negative direction, as x approaches 3 from the negative direction, this function is decreasing, and it will continue to decrease infinitely. So f of x approaches negative infinity. The next one, as x approaches infinity, what is f of x approaching? So here on the right side we can see what happens as x approaches infinity. The graph is moving to the right. It's going to continue to increase, but what we are concerned about here is the value of the function. What's the value of y as x approaches infinity? The value of the function is decreasing, and it will continue decreasing until it gets infinitely close to this horizontal asymptote at y equals 0. So this function is approaching 0. And finally, as x approaches negative infinity, this is going to be what's happening on the graph as it goes to the left. What is happening to the value of the function? So as x approaches negative infinity, the values for y are decreasing. And this is going to get infinitely smaller until it gets infinitely close to the horizontal asymptote. So again, this is approaching 0. The value of the function approaches 0. And that's it on these ones. These are fairly easy if you can get the concept of looking for what is happening to your y values as x behaves in these different manners. Number 2, I want you to go ahead and work out by yourself using what we learned in number 1. Don't be confused by the existence of 2 vertical asymptotes. All you're going to do is use the appropriate asymptote depending on the question. So as x approaches negative 3 from the positive direction, we are using the asymptote x equals negative 3. When we get down to x approaching 5 from the positive and negative directions, we will look at the vertical asymptote x equals 5. So go ahead and do those. For number 3, we are asked to write the equation of a graph with the following characteristics. So number 3 is asking us to reverse the process learned on days 2 and 3 of graphing rational functions. The first characteristic here is that there's a hole at x equals 1. So remember that on day 3 we learned that there are wholes when the denominator equals 0, but specifically at those factors that occur in both the numerator and denominator. So let's start by making this equation equal 0. We will do that by subtracting 1 on both sides. X minus 1 equals 0. And I'll put an empty bar over here that will fill in. So this means that in the numerator we have a factor x minus 1, and in the denominator we have a factor x minus 1. There are vertical asymptotes at x equals -4 and x equals 3. These also occur by setting the denominator equal to 0. So let's make the first equation equal 0 by adding 4 to both sides. X plus 4 equals 0, and subtracting 3 from the second equation. X minus 3 equals 0. This gives us two more factors for our denominator, x plus 4 and x minus 3. Next is the x-intercept, which occurs at x equals 0. Our x-intercept is the same thing as our root, and these occur when the when the numerator equals 0. So here x equals 0. That means that our factor for the numerator is going to be x. And finally, our horizontal asymptote occurs at y equals 0. So our horizontal asymptotes can be found by comparing the highest degree in the numerator and the highest degree in the denominator. Let's look at what we have so far in our equation. In the numerator, if we were to distribute this x, we would have x times x, meaning that the degree of the numerator, the highest degree, would be a 2. In the denominator, the highest degree is going to be a 3. This is because if you distributed each of these, you would end up with first a trinomial if we distributed the first 2, and the highest degree of that trinomial would be x squared. But then when you multiply by this other factor, x minus 3, we would have x times x squared, giving us an x cubed. So the highest degree in the numerator is 2, the highest degree in the denominator is 3, meaning that this is bigger on bottom. When it is bigger on bottom, our horizontal asymptote is y equals 0. So that means we do not need to make any changes for our horizontal asymptote to be y equals 0. So to finish this problem off, we're going to make an equation by saying y equals, and that is your answer. Please come ready with number 2 so that we can discuss that in class.